Hello. In this module, we will further extend the idea of Bernoulli trials to a concept of Bernoulli process, which will lead to the binomial distribution. So a Bernoulli process is a sequence of Bernoulli trials under few conditions. And these conditions include that each trial results in one of the two possible outcomes, which could be classified as the success or failure. But one aspect of these two possible outcomes cannot be ignored, is that these outcomes should be mutually exclusive, which means that there should not be any overlapping in the ideas. When we say something to be success, it should not overlap with the failures. The other condition for the Bernoulli process is that the probability of success will be denoted by P, and this probability of success will remain the constant from one trial to another until the end of the trials. And the third property, or the condition, will be that all the successive trials should be independent, which means that second Bernoulli trial will not have any impact from the first trial, whereas second will not have any impact on the third trial. A Bernoulli process gives rise to a probability distribution known as the binomial probability distribution, which requires almost similar type of conditions as of Bernoulli process, but it adds one more. What it says is that for the binomial distribution, 4 conditions should meet. And the very first condition says that the procedure has a fixed number of trials. That whenever we perform the random experiments of various Bernoulli trials, our Bernoulli process should have a fixed n, where n denotes how many number of times a Bernoulli process will be repeated. Rest of the 3 conditions are the same as of the Bernoulli process, which says that there will be success or failure, which will be 2 possible outcomes. And the probability of success will remain constant from trial to trial. And lastly, it says that successive trials must be independent. The given function is known as the binomial probability mass function. This probability mass function can be read as n choose x, p to the power x, 1 minus p to the power n minus x. You probably, this function will sound familiar to you, which it has 2 portions. One portion is exactly similar to the Bernoulli distribution. But the difference in the Bernoulli distribution and the binomial probability distributions are that Bernoulli distribution has only 1 trial, whereas in the binomial distribution there are more than 1 trials. The probability mass function of the binomial probability distribution will take value 0, other than the possible values of our random variable x that can only choose values from 0 up till n. If we have to find out the probability of n plus 1 using the binomial distribution when our experiment is repeated n number of times, the probability mass function will return a value 0. So from this probability mass function, you will notice that there are 2 possible outcomes, success and failure, whereas the probability of success is denoted by P and probability of failure is denoted by 1 minus P, which is also denoted by Q. There are a few components of the probability mass function of the binomial probability distribution. The first one is n. And keep it in mind, this is a small n, which denotes the number of fixed trials. It denotes the number of times we will repeat our Bernoulli trials. X is the specific number of successes in n trials. P is a probability of success in one of the n trials, and Q is a probability of failure in one of the n trials. Whereas P of X denotes the probability of getting exactly X successes among the n trials. Hence, this is the probability mass function of the binomial probability distribution. As I shared earlier, that it has two components. The first component, which is n choose x, can also be written as n factorial divided by x factorial multiplied by n minus x times x factorial. This portion of this probability mass function talks about the number of outcomes with exactly x successes among n trials. If there will be one trial, n choose x will be 1. Whereas the second half, that is p to the power x, 1 minus p to the power n minus x, it's the probability of x successes among n trials for any one particular order. So we will discuss 3 methods for finding the probabilities corresponding to the random variable x that follows the binomial probability distribution. The first method will be by using the probability mass function or the other binomial probability formula. The other method will be using the table of probabilities. And lastly, we will work using a software. So, the probability mass function can be described by these 2 equations. So, let's use a more simplest form. Suppose we have n equals to 5, which denotes that our Bernoulli trials are repeated 5 number of times, with probability of success to be 0.60. Then the probability that binomial trials yield 4 successes will be given as probability of SSSSF, where first 4S will represent 4 successes, and the last F will represent the 5th failure. We use a multiplication rule to find out this probability, but keep one thing in mind, that that's only a one way to do it, because there is also a possibility of getting failure within and 4 other successes, or it could be failure in the beginning and 4 other successes, or there are so many other possibilities that could arise, because it only says that find the probability that the binomial trials yield 4 successes. It doesn't say that what order will they choose. So this is just one combination that we have talked about, but it could be more. So using the multiplication rule will make it more and more complex, because we will have to find out the probability of each sequence of these successes and failures to find out the probability. And it will become much more complex if there will be 2 failures or 3 failures, or as it grows. So what we do is that whenever we do this binomial probability distribution and we use this binomial probability distribution to find out the probability, we follow the 4 steps. And this is how we think. First of all, we identify a success. Then we determine P, the probability of success. Then we determine N, that's how many number of times that Bernoulli trial has been repeated. And lastly, the binomial probability formula for the number of successes X, which is given by the given equation. So using binomial probability distribution, with N is equals to 5, P is equals to 0.60, probability of failure to be 0.40, and our event of interest that says that we will yield 4 successes will be given as the probability of X exactly equals to 4. This probability can be obtained by using this formula and simplifying by 5 factorial divided by 4 factorial into 5 minus 4 factorial and substituting all those given values into the probability mass function of the binomial probability distribution and solving it, the value turned out to be 0.2592. So this is rather easier way to calculate the probability as compared to the multiplication rule. And this is quicker as well. And it includes all different other possibilities that could arise as the result of this random experiment of obtaining 4 successes and 1 failure eventually. So using the binomial probability distribution, we can construct a whole binomial table, or a table of the probabilities, keeping in mind that n is equals to 5 and p is equals to 0.6 and q, which is the probability of failure, is 0.4. All the possibilities that could arise as the outcome of this random experiments are either no success. No success will be denoted by x is equals to 0. Or it could be 1 success, which is denoted by x is equals to 1. And so on, it could be 2, 3, 4, and all 5 successes. As we know that x can take possible values as 0, 1, 2, 3 up till n. And in this situation, n is 5. Therefore, we'll get 6 different probabilities. We use the probability mass function to find out all these probabilities. So it shows that there is 23% chance to get 2 successes. One has to be very certain that x and p both refers to the sample category, being called as success. I want to make one thing clear, that when we talk about anything to be a success, it does not always have to be a material success that we often take in our real life. Having a disease could sometimes be an event of interest, and an event of interest is considered to be as our success. Similarly, when the sampling is conducted without replacement, then consider events to be independent if the n is less than 0.05 times the n, capital N, which is the population size. Thank you.